You're looking at live pictures of the sky above the Utah Test and Training Range. In less than an hour, a 4.5 billion-year-old piece of the ancient solar system will be landing here in the desert. This is live coverage of NASA's OSIRIS-REx sample return.
There's been nothing like OSIRIS-REx in NASA's repertoire. I like to call it the Daredevil spacecraft.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid bennu and back.
Welcome and thank you for joining us live from the Army's Dugway Proving Ground in Dugway, Utah. This is special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space. I'm Lauren Ward, and joining me is Dr. Jim Garvin, Chief Scientist at NASA's Goddard Space Flight Center. He's a planetary geologist by training and also probably one of the most excited people around here today.
Lauren, literally, I'm over the asteroid.
Better than over the moon, over the asteroid. Well, I'm excited to share the stage with you today. We've got a lot to discuss and a huge adventure straight ahead. And for those joining at home, Jim and I will be taking your questions live throughout the show. You can send those our way by using the hashtag AskNASA on Facebook, X, YouTube, and Twitch. And if you want to follow along this final guide to the mission at home, scan the QR code on your screen and check out NASA's Eyes on the Solar System, where you can view a complete 3D simulation and follow the OSIRIS-REx sample return capsule to the ground. And during the broadcast, you'll hear directly from the mission team, so listen very closely for those operational callouts. Before we get into the action, though, tell me, Jim, what are you most excited about?
Lauren, it's the masterpiece of engineering we have here. Just think about this. In 50 years, we've gone from bringing things on the moon back with crews to all robotic sample return for science that's literally beyond words. It's sublime. So we can't wait to see what we're going to learn.
We cannot wait. So OSIRIS-REx is an acronym for Origins, Spectral Interpretation, Resource Identification, and Security, Regolith Explorer. Yes, it's a mouthful, but the mission describes an audacious objective. Send a probe on a long journey to an asteroid, map it, grab a sample, then bring it back to Earth for analysis. Following launch on September 8th, 2016, the plucky probe took an extraordinary route through the solar system until it reached the asteroid Bennu. Then, after more than a year of mapping the surface in exquisite detail, OSIRIS-REx made a careful descent in October 2020 to collect a sample. 3 years later, we are here at Dugway Proving Ground in the deserts of northeast Utah, awaiting that capsule containing the sample, which experts tell us is essentially a time capsule of the ancient solar system. We've got a great team joining us this morning as we experience this thrilling conclusion of this grand adventure. Sophia Roberts is located near our landing zone, and she'll be speaking with some key players in the mission. We'll also hear from James Traley, who will be tracking mission operations and bringing us real-time updates, essentially our eyes and ears inside mission control, which sounds to me like a good place to jump into the story. James, good morning. How are we looking?
Yeah, good morning, Lauren and Jim. It's already been a very bright early morning for all of our team members involved in this mission. Just a little bit further north from us, about 4 hours ago in Waterton, Colorado, the team met to assess the readiness to release the SRC from the main OSIRIS-REx spacecraft. And I'm very happy to report that they gave the green light, they gave the go command officially to release the SRC from the OSIRIS-REx. Let's listen in on what that command sounded like. That command came after more than almost 4 billion miles of spaceflight and years of planning, plotting, and dreaming about this asteroid Bennu. The SRC has now been separated from the main OSIRIS-REx spacecraft and is coming in rain or shine today. So team members are keenly aware of the weather conditions out on the range. It's looking pretty great for today. We did have a bit of rain the other day, which softened up that landing spot just enough to make the SRC land perfectly smooth on that surface. The temperatures are going to be around the 50s, 50 degrees Fahrenheit. Low winds out there, calm winds at the surface around 6 miles an hour, pretty light. Very clear skies this morning as well. As we were actually driving out, I saw a shooting star, a meteor, and in just a few moments, the SRC itself will be streaking across the skies as we begin to track it. Just a few moments ago, We heard the helicopters take off from here to head out to wait just at the edge of the landing ellipse. Our high-altitude plane is up in the sky, ready to take images in the infrared of our SRC, and we are here ready to go to cover all of today's mission events. I'm going to be right here with you all throughout the process as we get closer to that entry, descent, and landing. But for now, back to you, Lauren and Jim.
All right. Thanks, James. We'll be back to you for mission status updates throughout the morning. For now, let's give you a quick geography lesson on where we are today. We are sitting about 85 miles southwest of Salt Lake City in the heart of the Dugway Proving Ground, a historic Army facility. In less than an hour, the sample will touch down in our landing ellipse at the Utah Test and Training Range, managed by the Air Force, about 13 miles north of where we're speaking right now. Mission teams have set up a clean room just 1 mile away from us, where the sample will end its journey today. Tomorrow morning, a C-17 aircraft will take off from the runway behind us and deliver the sample to NASA's Johnson Space Center in Houston.
Unbelievable.
Unbelievable.
Can't wait.
Oh, gosh. I can't wait to see that C-17. Oh, that's going to be breathtaking. We have a lot of ground to cover, and we'll be bringing you into the heart of the action. For all of NASA's many missions over the years, OSIRIS-REx lives in an extremely rare category. It not only ventured out into space with cameras and sensors, but it's bringing a physical sample of the ancient solar system back to Earth for detailed analysis. Mission planners selected a small asteroid called Bennu as their destination. Following a successful touch-and-go procedure to grab a sample on October 20th, 2020, OSIRIS-REx has been making its way back to Earth. It's been a thrilling ride, already packed with technical achievements and scientific discoveries. Today's historic landing continues that saga, promising exciting research ahead. Beside our main event this morning, we've got a ton of extremely cool stuff. We'll hear from a special guest astrophysicist whom you probably recognize more for his chart toppers. We'll speak with one of the helicopter pilots about his role in getting recovery teams out to the landing site and bringing the capsule back home. And we'll even hear from the cast of the film Asteroid City. And of course, we'll give you a front row seat to the mission itself, the science, the engineering, and why a mission to gather space rocks, well, rocks.
Right?
NASA's first asteroid sample return happens in less than 35 minutes. Let's now take you to Wig Mountain, where our field reporter, Sophia Roberts, is standing at the forward edge of the vast landing zone, where she joins us live now. Sophia,
Thank you,
paint us a picture.
Lauren and Jim. Now, it is a bright and chilly morning, but the excitement certainly is rising. Now, let me give you a lay of the land of what is going to happen today. The sample return capsule is going to hit the top of the atmosphere at approximately 8:40. It will descend through our atmosphere for 13 minutes before touchdown. Once it does touch down, our team with the recovery team will go to the sample or the capsule and start that carefully rehearsed recovery process. Now, I am on the edge of the landing zone that we call the ellipse. It is a huge landing zone that is larger than the size of Rhode Island. And behind me are the helicopters that will be taking those recovery teams to the capsule once it lands. Now, these teams are prepped and ready to go. We're just waiting for that capsule to arrive. Back to you, Lauren.
Wow, Sophia, I think she has the best seat in the house.
Oh my God, take me there.
I want to go there. All right, let's get some quick facts about the OSIRIS-REx spacecraft. Filled with fuel, the vehicle weighs more than 4,600 pounds. That's about the same size as 3 large cows. Did you know that, Jim?
I did not, and I'm afraid of those cows.
Let's stay away from the cows. With its solar arrays extended, the spacecraft is about 40 feet long, or the size of a short school bus. The solar arrays can power up to 3,000 watts, which is the same as a portable generator. Once on Bennu, the 11-foot robotic arm collected dust and pebble samples, while the cameras got up-close images of the asteroid. How about that? And then, of course, there's the SRC, or the Sample Return Capsule, the capsule that's separated from the main vehicle and is currently on its way to our landing zone in the Utah desert. So, Jim, I think importantly, the team can't just open up the capsule right on the desert floor, right? What happens next?
So next, we have to safe it, we have to bag it, we have to contain it, and transport it to the clean room about a mile from here. And in that clean room, we will actually bring the sample return capsule in, take off the back shell and the heat shield, and carefully arrange to nitrogen purge that special sample container inside, so it does not introduce any contamination from Earth, because we want asteroid, not Earth.
That's right. And I love missions like this because I find my own imagination just bursting with possibilities and questions. And so with about a little bit more than 30 minutes to go before the SRC hits the top of the atmosphere, we're going to take a few minutes to dive into the nuts and bolts of the mission itself. We've got a great mission overview to help explain. Take a look.
OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS-REx spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55.
Wow, I get chills every time I see that.
Me too.
Amazing. All right, so we know you have questions, so please continue to send them to us using the hashtag AskNASA. But before we go any further, I've got a question for you, Jim. Why is the mission called OSIRIS-REx? It sounds like a new hybrid kind of dinosaur or something.
It does, but it's actually the name of an Egyptian deity, a bird deity, but it means all the stuff the mission's going to be doing. So we're going to be searching for clues to the origins of our solar system chemically, looking at how we can ground truth all the data we have for asteroids from Earth, other spacecraft right up close with samples. We're going to look at the resource potential of asteroids, metals, hydrated water and hydrated minerals, and also consider security of our planet from these kinds of objects. It's a big name with a big mission with many things it has to do. It's multiple missions in one.
Yeah, 3 missions in one, in fact. We know we have a global audience for this event, and throughout the morning, we'll be taking questions submitted via social media. So let's take one now. All right, what do we have? At S4Mule_B asks, what's the significance of studying asteroids like Bennu for advancements in planetary science?
These are literally the time capsules of the early solar system with those bits and fragments we can never get here. So we go and bring them home to connect ourselves to the place we live, our solar system. So that's one of the big takeaways of this. We will read the clues of Mother Nature on how our world works in the context of all the rest of the planetary system.
Fantastic. All right, let's take another question. What do we have? All right, from at Endanger817. Approximately how large is the sample size and what kind of analysis will be performed?
So it's about 8 or 9 ounces. It's about a size of a baseball and a half, and the kind of analyses are amazing. There are toolkits and instruments that can look at nanoscale characteristics that you wouldn't imagine. We could see the hairs on a foot of an ant, but we'll look at those in the context of another object in the solar system. So, wow.
Wow, indeed. All right, we'll be taking some more questions throughout the morning. Okay, so let us head back to the ellipse to talk to Sophia. I understand, Sophia, you've got a critical team member with you. Take it away.
Thanks, Lauren. Yes, I am joined right now by Stu Wiley, who is the Oscar or on-scene commander of this recovery mission. Thank you for joining me, Stu.
Thanks for having me, Sophia.
All right, so you are the person who kicks off this whole process before even the recovery team gets on the ground. Can you walk us through your process?
Yeah, so essentially what's going to happen is that once the capsule is undershoot, we'll have a better idea of where it's going to land on the range. And based on that, I'll know exactly what kind of weapon systems we used in that area, what kind of tests we've done in that area. So I'll know better what kind of hazards are in the area. Once I land on the ground, I'll do an initial sweep of the area and methodically move towards the capsule and mark any kind of hazards that I find, whether it be munition hazards, of course, and or the industrial hazards, and even the environmentally sensitive areas that we have out here. So.
All right, and how did you prepare for this today?
So preparation has been in the process for a long time. Between myself and Jasmine Nakayama, we've got 40 years worth of explosive knowledge. Most of it is on this range here, so we know the ranges very well. The team and the UTR have been working together, both Lockheed and NASA, and we've been doing rehearsals so that we are more familiar with their capsule, and they're more familiar with our terrain here as well. Yeah, so.
And this is an active proving ground here. So what are the other steps that we have to ensure that our teams are safe?
Yeah, so at the Utah Test and Training Range, we do have a lot of different hazards out here. Like I said, the weapon systems that we test. We're going to keep them safe from that. We have, again, done many of the preparations with them already. They've taken safety briefings. They've been briefed on the actual items that we've dropped out here in their range safety brief. One of the hazards that we're going to be dealing with, though, is the helicopters that you see behind us, and they've been through practices getting on and off the helicopters and working in and around them. But I think the biggest hazard that we're going to have is slipping. We had some recent rain, so that I think is going to be our biggest hazard, but it could be fun too. So.
Well, wonderful. I know that you have your last preparations for the day, so I'm going to let you go, and thank you very much for joining us.
Thank you, Sophia.
Thanks, Sophia. Stu's got a big day today.
Oh, my goodness.
A lot to do. All right, Jim, we know we have space fans from all walks of life all over the world. One super fan in particular is a well-known astrophysicist with an atypical side hustle. But I'm guessing you know him probably more from his side thing than his science thing.
Well, that's right. He's literally space royalty and rock royalty. Perfect for a mission to bring back rocks.
Just a true rock star. Let's let him speak for himself.
Hello, NASA folks, space fans, asteroid aficionados. This is Brian May of Queen, as you know, probably, but also immensely proud to be a team member of OSIRIS-REx. I can't be with you today. I wish I could. I'm rehearsing for a Queen tour, but my heart's there with you as this precious sample is recovered. Happy sample return day, and congratulations to all who worked so incredibly hard on this mission. Especially my dear friend Dante, with whom we already created this beautiful book. God bless you all.
Speaking of rock stars, joining us is NASA's Lori Glaze, Planetary Science Mission Director. Welcome, Lori.
Hey, good morning.
Great to have you here, Lori.
It's great to have you. And you and Jim go back quite a ways, right?
Oh, yes. Jim and I actually go back several decades, but we've been working together closely for many, many years, and it's so good to see you here. What an exciting moment.
Lori.
Thank you.
It is a really exciting day. So OSIRIS-REx is part of a larger autumn for asteroids, asteroid autumn, as we've been saying. Can you talk about some of the other missions that are happening this fall?
Happy to do that. It is really exciting. We have lots of asteroid missions, and actually 4 of them have major milestones coming up this autumn. right on the heels of the sample return happening today. In 2 days, on September 26th, is the 1-year anniversary of a little mission you may have heard of last year called the Double Asteroid Redirection Test, demonstrated for the first time humanity's ability to deflect the path of an asteroid. How cool is that? And then coming up on October 5th is the launch of a mission called Psyche, going to visit a special asteroid called Psyche also, which is one of only about 9 of asteroids that we think are made primarily of metal, have a very high metal content, iron and nickel. And then about a month after that, on November 1st, is going to be the first asteroid flyby of our mission called Lucy, which will ultimately visit Trojan asteroids that lead and trail Jupiter in its orbit around the sun. But in November, we'll fly by a main belt asteroid called Dinkinesh.
Wow.
Wow, check that out.
It literally is an asteroid arm. But Lori, one other thing, OSIRIS-REx, is a multi-purpose mission, all this great stuff you mentioned, and one of its key jobs is to help us with planetary defense. How does it do that? Way out there.
So actually, OSIRIS-REx gave us some really important new information about an effect, a force that occurs on asteroids called the Yarkovsky effect. And what that really is we know there's gravitational pulls on the asteroids, and we can predict that with our trajectories, but Yarkovsky effect says that the sun's radiation heats up one side of the asteroid, and then as the asteroid rotates, the radiation radiates off into the deep space. And that actually kind of acts as a force that kind of pushes back against the forward trajectory. And so it changes our predictions on where the asteroid might be. Over time, it really makes a difference. And OSIRIS-REx gave us some fantastic new measurements on that effect.
Unbelievable.
Wow, that is truly unbelievable. Nobody appreciates the planetary defense aspect more than me and Jim.
Yeah, we want to be safe.
Big fans. Really, really quickly here. This isn't the end for OSIRIS-REx. What's next?
Yeah, so really exciting. Now that the spacecraft has released the capsule successfully, about 20 minutes after that release, we're now repurposing the spacecraft for a new mission called OSIRIS-APEX, where APEX stands for Apophis Explorer, and it's off on its new mission to explore the asteroid Apophis, which is going to have a close flyby of Earth in 2029.
All right, stay tuned, everybody.
Unbelievable.
That is fantastic. Well, thank you so much, Lori, for
Thanks,
joining
Lori.
us. You're going to stick around for the show, right?
Oh, absolutely.
Absolutely. Okay. This will be the biggest U.S. sample return since the Apollo mission to the moon. But this is not the first time that anyone has captured a piece of an asteroid. On the arrival of the historic OSIRIS-REx sample, we celebrate that the Japanese Space Agency, or JAXA, has already visited 2 asteroids, Itokawa in 2005 and the asteroid Ryugu in 2019. The missions Hayabusa and Hayabusa 2 proved that it could be done and paved the way for today's ambitious goals of this daring enterprise. All right, let's send it back over to James for an update on mission operations. Go ahead, James.
Yeah, thanks, Lauren. So everything continues to be nominal. I've been tracking the mission status here. Everyone looks dialed in, ready to go. You saw a few moments ago Sophia with Stu Wiley, our on-scene commander. He's ready to go. He understands the mission. They are ready to get out and recover that sample today. And as I mentioned earlier, just a few moments ago, actually I guess a couple hours ago at this point now, the SRC was released from the main OSIRIS-REx spacecraft. When that release took place, it was given an initial spin, which kind of preserves its angular momentum, its speed as it's coming in to Earth's atmosphere. It's similar to throwing a perfect spiral on a football, and teams are hoping for that perfect touchdown today. What you're about to see is basically the equivalent of throwing a touchdown pass over 10 football fields away and landing it perfectly in that end zone. So you can see on your screen now the mission operations team. They are just next door, dialed in, ready to go. They've been monitoring the vitals of the SRC all morning. They've been there in the room, prepared and ready to go. I'm sure they are absolutely thrilled for this moment. They might even see themselves on the screen there in a second, but they are hype and ready to go. This is the Lockheed Martin team just a little bit north of us in Waterton, Colorado. They are also dialed in. They're the ones who gave that initial command this morning to release the SRC from the main OSIRIS-REx spacecraft. You just heard from Lori that OSIRIS-REx is now on its way to its extended mission. OSIRIS-APEX visiting that near-Earth asteroid Apophis. A lot coming up in just a few moments. We're going to hit that key milestone of entry, descent, and landing. 13 minutes of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range. A lot coming up in just a few moments, but for now, back to you, Lauren and Jim.
Thanks, James. Very soon, NASA's Artemis program will be bringing us more cosmic samples to study by visiting a familiar beacon in the sky. Give us 60 seconds, and we'll give you the moon. Artemis 3 will be the first sample return mission of NASA's Artemis program, sampling rocks and regolith from one of 13 candidate regions on the moon, all located near the lunar South Pole. The Apollo lunar landers returned a treasure chest of samples that taught us about the history of the solar system, dating back about 4 billion years ago. Artemis missions will explore areas near the South Pole on the rim of the moon's oldest basin, the enormous South Pole Aitken Basin. Artemis will explore areas nearly 1 billion years older than those explored by Apollo. Lunar samples from Artemis 3 and future missions will help scientists interpret the impact history of the moon and Earth, as well as increase our understanding of planetary processes. OSIRIS-REx, the first U.S. mission to collect a sample from an asteroid, will return samples from asteroid bennu. The rocks and dust collected will offer generations of scientists a window into a time when the sun and planets were forming over 4.5 billion years ago. Samples from OSIRIS-REx and Artemis could rewrite our understanding of the evolution of the solar system. And that's a look at your Artemis Moon Minute. Boy, Jim, how can you not get excited about that?
Oh my gosh.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
All right, thank you, Lauren. We are under 20 minutes away from EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day more than the principal investigator of the mission, Dante Loretta. Thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there. We're also interested in the air quality and any water that might be standing, just so in the very rare event that any of that material somehow comes into contact with the sample, we have a record of it and it won't compromise our science.
Ah, wonderful. And I think one of the really exciting things about a mission like this, especially with you working with the University of Arizona, is that you're partnering with educational institutions. So can you talk a little bit about the legacy that a mission like this has?
Yeah, thank you. I'm a professor at the University of Arizona in the Lunar and Planetary Laboratory, and our history goes all the way back to the Apollo missions. The founder of our lab, Gerard Kuiper, mapped the moon, helped pick the Apollo landing sites and the Surveyor landing sites, and we have been involved in every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
The moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right, back to you, Lauren.
Great, thanks, Sophia. Wow, I can't wait for Dante to get his moment in the sun.
Goes Dante.
That is amazing. All right, so Jim, the whole OSIRIS-REx spacecraft is not coming back today, right? It's just a part of it.
That's right. This is the whole spacecraft, 40 feet long, the size of a school bus. But this special little thing here, the sample return capsule, is bringing home the goodies. And that's what we've just released, and it will be entering the atmosphere, and you'll be hearing all about it. And the samples were collected at the asteroid back in October of 2020 from this TAGSAM thing that inserted them in the capsule, and the capsule was released. So that's what comes home. The rest of this goes on to Apophis.
That's right. We just heard Lori talk about that. But let's move over and take a look at this replica SRC capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies, the sample return canister and the small sample canister. So this is the vehicle that that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is. And it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment and went through all the operations, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from bennu, so we can study them here on Earth and not contaminated by our wonderful Earth.
That's right. And you know it's the actual SRC that they use because it is covered in dirt, as you can see on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
it's the real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
SciFly's mission is to collect visual, infrared, and spectral data on spaceflight vehicles, including the OSIRIS-REx sample return capsule on its return to Earth. This gives engineers and scientists unique insight into our most challenging questions about hypersonic fluid dynamics by providing data critical to flight safety systems. The scientifically calibrated in-flight imagery team uses ground-based sensors and instruments flying on various aircraft to image asteroid sample returns, launch abort systems, parachute tests, rocket launches, and capsule returns, including Artemis 1 on both launch and reentry. The data we capture provides engineers with information on vehicle performance relative to what computational tools and wind tunnel tests predict. It takes extensive planning to get it right. Upon its return from the asteroid belt, the OSIRIS-REx capsule will be traveling at 12 kilometers per second, or about 27,000 miles per hour. That's nearly twice as fast as objects coming back from low Earth orbit, and it will be among the 4 fastest human-made objects ever to fly in Earth's atmosphere. In partnership with the Japan Aerospace Exploration Agency, Rocket Technologies International, and universities in Australia and Germany, SciFly is coordinating 3 ground stations and 4 aircraft to collect data on the sample return capsule's trajectory, heat shield performance, and the plasma environment surrounding the capsule as it speeds to the surface, all of which will help NASA understand its performance and help future planetary entry missions succeed.
Joining us now is NASA's Kate Calvin, Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made to, a day like today a possibility?
A mission like this takes a big team, both within NASA and without. So outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland. The sample is going to be going to Johnson Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation. Wow. We have a science team led by the University of Arizona. And then we have
recovery operations.
Canada and Japan.
Helicopter 1 has departed work to station keep outside the landing ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science, an expert on how our planet works and climate, can you tell us how this asteroid mission, the samples we return, might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel to you?
It's great. The environment here is so nice. Being with the team and thinking about, this spacecraft launched 7 years ago. And now there's all this amazing science just around the corner.
Can you believe it? The team has really been working hard. And are you going to stick around for the show?
Awesome.
Fantastic. All right. Well, Kate, thank you so much for joining us.
Thank you.
Thanks, Kate, for all you do.
Thank you so much. This seems like a perfect time to dig into some more information about bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because
Recovery
of its
operations.
organic
Helicopter
compounds
2
and
has
mineral
departed
codes.
WIG. The station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent
Whoa.
progress. Fantastic. All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest object to be orbited by a spacecraft. How fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
Okay, 2 of the helicopters have already just departed, so the team is already in the recovery process, or at least the beginning phases of it. But right now, we are waiting to hear precisely where the capsule is going to land before the rest of the teams head on over to that location. Now we are about under 10 minutes away from the capsule hitting the top of our atmosphere, and we are eagerly anticipating this largest sample of ancient solar system material that we have received since the last Apollo mission in 1972. So that is 51 years since we've had such a pristine and large sample of ancient solar system material. It's a really big day for science, and we're just in the beginning phases of today, but we are certainly excited to hear about what will happen and see those parachutes finally descend through our atmosphere. So yes, we're certainly excited, but this is just one phase of this amazing mission. I'm going to send it back to you, Lauren.
See the operational milestones we're expecting throughout the morning. SRC separation already happened, and the capsule is now heading for its rendezvous with Earth's atmosphere. Jim, it always appears like these operations are simply inevitable. You know, we grabbed the sample, we flew it back to Earth, we're headed in for landing, but it's never that simple, is it?
No, not at all. And so we have a lot of critical events that take masterful engineering. We have to hit the top of the atmosphere, transition through a high G, high heat environment, go from 27,000 miles an hour down to eventually 11 for that safe landing. All these things involve changes in environments, forces, things that could disrupt our sample and change them, which we want to document. And so we really want to understand this and finally bring it to rest so we can then bag it and encapsulate it so we can eventually get the sample into our clean room here. So we're ready to transfer tomorrow to Houston to the Johnson Space Center. So this is a big process, well rehearsed by a masterful team.
Absolutely, and contains, work from thousands of individuals who are making this happen. All right, so we know that you're submitting questions from all over. Let's take a few more social questions. All right, what do we have? At Dev Saran at 5342461. What are the preliminary steps to take to test a sample? The preliminary steps.
So first thing we do is, of course, bag it here and get it into the clean room and get that sample, that sample canister inside the sample return capsule, get it under nitrogen purge, meaning we flow nitrogen gas so no Earth atmosphere and microbes get involved. That'll happen today. Period of few hours, and then tomorrow we transfer to the Johnson Space Center in Houston, Texas, where all the fun happens at the Astromaterials Curational Facility, where we've done moon rocks and samples of interplanetary dust and lots of things. Those colleagues in a special clean room perfectly designed for this mission will unpack those precious samples in the small sample canister, the small device that was used on the end of the TAGSAM, and they will go through a process to get it checked out, to do early reconnaissance, and to protect it very carefully.
That is incredible. And they built that whole clean room. No other asteroid samples before.
Right.
This is the first one.
First ever.
First ever. As the SRC approaches the edge of Earth's atmosphere, we are just moments away from the world's largest ever asteroid sample return. Jim, what are you feeling right now?
I am literally tingling all over with exhilaration. This is a small step for a capsule and a giant leap for science.
It really is. And if that's one thing we can impart, that is it. This is a huge, huge milestone, a great achievement. So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations. Helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting next couple 13 minutes here, and you'll hear a couple call-outs come in from just next door in our mission operations team as they begin to get us ready for this key moment. It's a journey of 3.86 billion miles, getting reduced to the scale of mere miles, 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. You see on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here. We're about 20 seconds away. You see the team at Lockheed now, all standing ready on the edge of their seats. This team, I'll remind you, just a few hours ago, gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing. We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC, is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC, a phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone, we'll be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah Test and Training Range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, At this time, 8:44 a.m. Mountain Time, the OSIRIS-REx spacecraft is at its closest approach to Earth. That will be on to its extended mission, visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere. And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft. You can see our SRC. Streaking in. This is from our high altitude cam. Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here. As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within, that just a few years ago was on the other side of the solar system from us sampling an asteroid bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. We see
studio milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety of different tracking assets. And you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid bennu at sample site Nightingale to the rugged terrain of the Utah Test and Training Range. Looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend with a slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years, really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. According to my watch, we're about 5 minutes away from landing with our SRC. And as we heard a few moments ago, helicopters 1 and 2 are already staged and ready to begin those recovery operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
EDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath. The team on the WB-57 doing
EDL milestone. We have touchdown. I repeat, EDL. SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It was in a rush to get back here, carrying amazing amount of scientific information within. The team is eager to crack that SRC open, get the sample canister within, and begin the process of understanding the origins of our solar system and potentially the origins of life. We're not in the clear just yet. A key piece of the mission is about to get underway. This is the recovery operation phase. Once the team has officially confirmed the exact touchdown location, they'll be flying out on 4 separate helicopters and will operate much like a Formula One pit crew, if you will, to recover the SRC, take environmental samples at the landing zone, the LZ. Everyone has a role to play. It's going to be simultaneous action as they get that SRC recovered and begin to do an environmental safety sweep, collecting samples along the way. You see our mission ops team just next door. once again remind you that the sample canister itself is not actually going to be opened here at Dugway. The next phase of the operation is simply to get that SRC into the portable clean room that has been specifically set up for this recovery operation. The team will then remove the heat shield protecting the SRC and its precious cargo within the entire descent through the entry, descent, and landing, remove the back shell, and then extract the sample canister within the tag sim that just a few years ago collected pieces from the asteroid Bennu. Today, the goal is to get the sample
recovery
canister.
operations. Helicopters 3 and 4 are leaving rig for the landing ellipse.
You see some big smiles from the team there. They are getting those helicopters out to the landing ellipse now to begin those recovery operations. The first person to approach the SRC is Stu Wiley, our on-scene commander. You see the helicopter, the last of them, taking off from the Wig Mountain just at the edge of that